100,000 years ago, the world was cold and getting colder. Buried under thousands of feet of ice, North America was descending toward the last glacial maximum, when the glaciers blanketing the northern hemisphere would reach their greatest extent. As this ice age advanced, mammoths and other fearsome megafauna roamed the earth, and a new, curious creature began to populate the continent: people. As temperatures slowly began to climb, the ancestors of Native Americans flourished. The planet cooled and warmed in turn, and these changes varied by region. When European settlers first set foot on North America, their homelands were experiencing a warm period. A revolution was fought, and a new nation emerged. The Industrial Revolution that started in Britain brought change as well to the continent across the Atlantic. The telegraph and the railroad connected the coasts, and the population boomed. So too did fossil fuel emissions from burning coal, and the influx of carbon dioxide into the atmosphere set us on an unprecedented trajectory. At the same time, some began to investigate and understand humanity's role in the planet's climate. From the discovery that the greenhouse effect keeps Earth warm, to the identification of the atmospheric gases responsible for that effect, and finally to the linkage between human CO2 emissions and worldwide warming, mounting evidence pointed toward a stunning epiphany: we were already affecting the Earth's future. Yet even as this realization unfolded, a second industrial revolution further spurred industrial growth. Human populations soared, and the First World War encouraged governments to embrace the mobilization of industrial societies. As the 20th century progressed, new oil fields in Texas and the Persian Gulf dramatically lowered energy prices. The Great Depression struck, followed by World War II. And the Cold War produced the first satellite and a race to the moon. At the same time, the scientific collaborations of the International Geophysical Year yielded new insights into our own planet and brought new funding and coordination to climate studies. Evidence of Earth's climate history embedded in minute layers of deep-sea sediments and Antarctic ice revealed a delicately balanced system, sensitive to small changes. Two successive energy crises ignited new interest in alternative forms of energy. Yet carbon emissions from the burning of fossil fuels continued to climb. By the end of the 1980s, scientists suspected that the climate was changing, that the world was warming in response to new pressures as it never had before. Some within the global community saw a need to take action, and efforts to mobilize took shape. Still others resisted the call to arms, unconvinced by the accumulating evidence, or worse, determined to ignore it. In 2016, the year of the Paris Agreement, annual average carbon dioxide levels in the atmosphere were already well above 400 parts per million and still rising. If we maintain this trajectory, it will be impossible to avoid a catastrophic 2 degrees Celsius of worldwide warming, or worse. Already, we're seeing extreme weather, floods, and forest fires. If temperatures continue to rise, so too will sea level, endangering coastal communities the world over. What can we do? The challenge is daunting, but not impossible to overcome. Some nations, and individual states in the U.S., are stepping up to address the threat, pledging to stop the warming before it reaches that 2-degree threshold. The future is in our hands.